The Internet of Things has the potential to improve our lives dramatically. IoT devices with sensors and actuators need electronics to connect the world of things with the digital world of the Internet. Yet software runs the IoT electronic hardware. Since IoT devices need to be smart, cheap and capable to run with extremely small amount of energy known as ultra-thin IoT nodes, IoT software must also be ultra-thin with extremely small memory footprints and ultra-low energy support. At the same time, software must provide smart functions including real-time computing capabilities, connectivity, security, safety, and remote update mechanisms. These constraints put a high pressure on IoT software development. Compact Project's goal was to provide novel solutions for the application-specific and customer-oriented realization of IoT nodes, with focus on software generation for IoT nodes with ultra-small memory footprints and ultra-low power consumption. This goal was enabled by the new IoT Platform Modelling Language, shortly IoT PML, that captures the IoT hardware, software stack, and non-functional requirements as well as functional properties. Its focus is to drive software generators for ultra-thin IoT software that consists only of what is required for smart functionality and nothing else. The IoT PML is a domain-specific modeling language suitable to IoT nodes, which is implemented as the UML profile. IoT PML supports both top-down and bottom-up design flow or its combination. When IoT PML is used for top-down design flow, you can refine system architecture and functional interface by using a predefined modeling patterns, enabling separation of interface definitions and system functionality visualized in different abstraction levels. Once the required details and non-functional quality annotations are added to model elements, you can generate code and optimize its structure. In case of bottom-up design flow, you can use IoT PML for linking model elements to external resources using URI, or import existing code or definitions of electronic components structured in IPExact into the model as an architectural view. Or you can simply use IoT PML for annotating non-functional requirements and functional properties of three kinds: power, memory, and duration. Their values are specified in a specialized language that supports constant values or triple values and can be traced to the appropriate model elements. When modeling behavior specification, you can define whether the duration is required or measured. The benefits are obvious. The approach proposed by the Compact project will make the development of IoT software transparent, much shorter and more efficient. It supports products being just in time on the market at a highly competitive price with increased reliability and stability. The meta-model-based approach and the carefully designed IoT PML both support the interchange of models along the complete IoT value chain.